I welcome you students to this module. In today's module we are going to learn about one of the most important data structures, which we call as stack. And as part of the learning objectives of this module, at the end of this module you should be able to do all these three things here. You will understand the basic concept of what a stack is, and also what are the basic operations we carry out on a stack, which are push, pop and the stack empty function. And also we will learn the array implementation of the stack, because we also have another implementation of a stack which we use, or where we use linked list to implement the concept of a stack. Now I want you to look at this jar kind of a thing here. As you see, the bottom is closed and you already see two letters in that. You can imagine that, you can very easily see that at the bottom of the jar there is the character A, and on top of that you have the character B. Now I have written here as stack of characters. Now what is a stack in general? From the real world, whenever we say a stack, it is nothing but several things put on top of the one on top of the other. Like for example, you can have a stack of books. I have a stack of books wherein I have one book at the bottom, and then on top of that I have another book, on top of that another book, so on and so forth. A pile of books. And also you can think of a stack as a stack of plates. For example, when you go to a buffet lunch or dinner, you have all the plates stacked up, one on top of the other, and we pick up the plate from the top of the stack. Same way, I have a stack of characters here, meaning I have characters, one character, and above that I have another character. Now if I put one more character into this jar, obviously if I want to put C into this, C will come here. Notice that C is at the top of the jar here, or top of the stack. Same way, if I put one more letter into the stack, that will again sit on top of C. So what I want you to notice here is that as you put characters into the stack, the one that you have put in last is at the top of the stack, because first I put C, then after that I put D, but the order is reversed here when you look at the top of the stack. Right now D is at the top of the stack. So that's why. And on the other hand, if you see, if I remove the characters, now if I want to remove one character at a time, obviously from this jar here, if you pop or if you remove one element, the only thing that is available to you is at the top. That is, when you remove, D is going to be removed first. So once D is removed, C is at the top of the stack. So C is removed, and once C is removed, the stack is right now like this. Now the top of the stack is B. B is removed, the stack will be like this. And once A is also removed, A will go out like this. And now the stack will be what we call as empty. And what the basic thing that we have to notice here is that the order of putting the characters into the stack was, first A was there, then B was there, then C was there, then D was there. The last letter to get into the stack was D. But when we removed, what is the first one that got out? D, which was the last character that got into the stack. That is the reason why the stack is generally known or called or referred to as a last in, first out structure. LIFO. L stands for last, I stands for in, F stands for first and out. So I will just write it here. This is last in, first out. So whatever item that gets into the stack last will get out first. Because there is an inherent order in the items that are put into the stack and that are removed, this is also referred to as an ordered list. It is a list, There is an order because what goes in last comes out. Now to come to the operations that we refer to when we are talking about a stack. First thing that I want you to understand is stack is a general concept. The behavior is defined. That is, all that is defined about a stack is that whatever goes in last has to come out first. And in order to do that, some basic operations are also defined. For example, the act of putting something into the stack is referred to as, so when something is put into the stack, we say that we are pushing something onto the stack. On the other hand, the act of removing something from the stack is known as popping. Same way, there are times when we have to check that whether the stack is empty or not. As you have noticed, when you pop all the letters, all the contents of the stack out, ultimately the stack will be empty. One thing that I want you to notice and know about is that you have to check the condition that the stack is empty in one particular case. That is, you can't pop from an empty stack because the act of popping will try to remove a character or an item from the stack. Obviously, you can't do that from an empty stack. So, one more function or action that we associate usually with a stack is that we would always like to check whenever you are trying to pop is that whether the stack is empty or not. Because from an empty stack, you cannot pop. So, when you are trying to pop something from the stack, we have to ensure that there are some elements or some items in the stack. So, these are the three important actions that are associated with the stack. Basically, what they do is very, very straightforward. Push will simply put an item onto the top of the stack. Pop will simply remove an item from the top of the stack. The isEmptyStack function will simply tell you whether currently the stack is empty or not. As you have seen, the stack size will go on increasing and decreasing. As you push elements into the stack, it will go on increasing in size. As you go on putting one thing on top of the other, the stack will increase in size. As you go on popping from the stack, the size will go on reducing. As it grows and shrinks with pushing and popping, the stack data structure is dynamic in nature. And also because we are pushing things into the stack, it is also known as a push down structure, in addition to being called as a last in first out structure. So, it is dynamic in nature, and because it grows and shrinks as you push and pop, and also because of the essential characteristic of a stack is that whatever goes into the stack comes out first. So, the LIFO nature is the most important characteristic of a stack. We have to some extent understood the basic nature of a stack, how it is defined abstractly. That is why sometimes it is also known as an abstract type, because we just define the behavior of a stack, how it should behave. Now, when it comes to actual implementation in a programming language, the idea of a stack, we can take two paths. That is, two alternatives are there in general. The first one, we can implement a stack using arrays. We can also implement the notion of a stack by using linked lists. In this module, I would like to discuss about the first alternative, which is by using arrays. And the next module, of course, we will discuss about how the same concept of a stack, which is a LIFO structure, by using a totally different representation, which is linked lists. Now let us assume that we are making use of an array to implement the notion of a stack. Now in this example, I would like to deal with a stack of integers. So where do we store integers as a stack? For that, I will take the help of an array. For example, the name of the array is A. As you know, the first element is always referred to as A of 0. The next element is A of 1, A of 2, so on and so forth. So now assume that this is the current state of a stack. That is, how many elements are there in the stack? There are 3 elements. The first one has gone into A of 0, second one is at 2, which is 20, third one, A of 2, is the value 30. And now, in order to push values in and pop values out from the top, we maintain another variable which we call as top. For example, here top is being shown to here. So actually, the value of top in this particular case is 2. That is, top is simply an integer variable which will hold the index number of the element, which is nothing but the top of the stack. What is the top of the stack here? Nothing but this array element, which is A of 2. The value is 30. It could be 40, 50, whatever. But what is the top of the stack right now? It is indicated by the array index, which is 2. That is, right now the top of the stack is at array element 2. That is what is stored in this top variable, which is 2. For example, now let us see how the push and pop operations can be carried out on the current state of the stack. It's very simple. Now, let us say I would like to put value 40 into this stack here, programmatically. Where will that go? Obviously, that has to go into array element 3. So how do you do that? Right now the top value is 2. So where will the next element get into? Into the next array element. How do we get the next element from the current top element? Current top is 2. So the next place into which the next element has to get into has to be 3. So that's why what we do is very simply top is equal to top plus 1. That is the first statement that you are going to write whenever you are trying to push, because whatever current top is, that has to be changed to the next element. So now top will become 3. Now where do I want to put this element 40? At A of 3 or A of top actually. So your code is going to be A cap top is equal to 40. Since at this point of time the top was 2, now it is made to 3, and at A of 3 the value is pushed. So it is simply a matter of managing the location. Current top is there, you want to push something on top of that, so we increase the index of the array, make it the next element of the array, and into that you put this new value. So because of this statement here, A of top, what is the value of top now? 3. So A of 3 is equal to 40, which is nothing but one more value you want to put. Same set of statements are going to be executed again. So whenever you want to push, first you will increase the current top value, make it one more, and using that as the index into the array, you put the next value. What will happen now? It is 3 right now. Top is equal to top plus 1. We'll again make it 4 here. And this statement here, right now top is 4. So A of 4 is equal to 50. I want to put it as 50 now. So whatever value you are trying to push is always pushed into the next array location. It's very, very simple. You just have to manage top. As you see here, top kept changing. First to begin with, it was at this location. When we pushed one element more, top was made to point to the next element. When you pushed one more element, top has shifted and it is now pointing to the top of the stack. As you see here, as you go on pushing, top will go on change. So top will go and increase. On the other hand, let us look at the other operation. Currently the stack is like this. The array is like that. Simply additional variable top is there, the value of which is 4. This is the current situation. Now I want to remove elements from the stack. So when I remove one at a time, the operation is pop. So what is the effect of pop? Effect of the pop is nothing but it should simply return, whenever you pop from the stack, that pop operation must make available to you the value at the top of the stack. That is, when I pop in the program, I must have the value 50 available to me. So pop is a function which simply returns the top value in the stack right now, and it will modify the top position, because once this is removed, top must go down. So whenever pop function is called, it must return whatever is at the top of the stack, and then top must point to the one below. That is the basic definition of pop. That is, when I pop, I must get 50, and at the same time, for the next operation, the top must have been modified, and it should be pointing to the position below. So how do we make that happen in C code? Currently the situation is like that. So simply what the basic steps that we can look at, I am going to write here. First, this statement here will put the value that is in A top into Q. What is this value now? Top is 4, so A of 4 is 50, so Q will get a value equal to 50. First requirement of the pop is over, that is, I got the topmost value. But since I have removed in effect the top element from the stack, the top must get modified now. And what should be the top now? Because one value has been removed, it must point to the one below. That is, top simply is made top minus 1. That is, earlier it was 4, now it will be simply 3. That is, in effect, top will simply point to 40. So as you push, top will go on increasing. As you pop, top will go on reducing. But always at any point of time, top is the variable which will give you the location at which the current top of the stack is. This is where I want you to notice that the operations in the stack are always done from the same end. Because this end is closed, pushing and popping both are carried out at the same end, which is maintained by this variable which we call as top. So as you can see here with these two statements, considering the current position like this again, just consider what happens with this statement. Q gets the value of 50 because currently the value of top is 4, A of 4 is 50. But once that is over, top must be modified, made 1 less. That is, top is equal to top minus 1. So you can see the symmetry between push and pop. What did we do there as push? Now assume again I want to push one more value. Once I popped, this will be the situation. 50 is popped. Right now the top of the stack is 40. Now I want to push, let us say, value 60. Again, what is done? If you recall, first top must be modified, then A of top is equal to the value that you want to push. So again, top will be made to the next element, and the 60 will be overwriting this here, and your top will be pointing to 4. So it's a very, very simple process. It just needs your bit of an attention here, that simply the stack grows, and at any point of time that value in top variable will hold the index of the array element, which is the current top of stack. And using that, when we push, we go up. When you pop, you go down. So this should be effected in your code using statements like this. Now let us consider the third operation. Not exactly an operation, but it's a function. When called, it will tell us whether the stack is empty or not. Obviously, you can very easily see that the stack will become empty when you pop all the elements, or when there are no elements in the stack, that condition is reflected as stack empty. Now in the programming, when you do a program or write a program, somehow there must be a condition using which you must be able to check whether the stack is empty or not. Just consider here, right now what is the value of top? top is 4. You pop the top one, 60 is gone. So top will become 3 here. Then one more popped, that is 2. One more popped, top becomes 1. One more pop, how many elements are there now? 1. What is the top index? 0. What happens when you pop now? If you consider the code, what did we do whenever we popped? We simply said got the value like this. What is the current value of top? 0. So A of 0, which is 10, that gets into Q. Then top gets reduced by 1. That is, carefully consider what happens with this statement now. The current value in top is 0, because always our array indexes or indices start from 0. So when there is one element in the stack, top will have a value of 0. But when you pop that also, the way we have written the code, the value of top will now become -1. That is, it will just point to an illegal array index, -1. So obviously you can see from this condition here that when top is equal to -1, what is it telling us? It is telling us that the stack is empty. So whenever in this kind of an implementation you want to test whether a stack is empty or not, this is what we are going to test, something like this. That is, if top double equal to -1. So this is the kind of test you are going to make in order to find out whether the stack is empty or not. So for every data structure like this, depending on the implementations, you must always think carefully about which condition actually tells us whether the stack is empty or full, or a queue is full or empty, so on and so forth. So whenever whichever data structures you are looking at, please pay special attention to how we determine in code whether a data structure is empty or not. We have just seen like how a stack works, what are the basic operations in that, in the array implementation. Now I would just like to quickly show you how the code is written for the 3 important operations on a stack that we have just discussed. First of all, we have decided that in array implementation, the idea of a stack, that is, a stack is housed or accommodated in an array. So for that we need to declare an array first. Assuming that for the purposes of the current situation, assume that I am dealing with an array of integers. So if I have, or it's a stack of integers. So when you are dealing with a stack of integers, I will go with an array of integers. If you have a stack of characters, you will have to declare an array of characters. If you have a stack of floating point values, then obviously you will have to declare a corresponding array. So that's what I want you to notice. Depending on the values, the type of values you want to store in the stack, the corresponding type of the array must be declared. Right now I am assuming that I am going to have a stack of integers. So I have an integer stack. Of course I have to give some size. I am assuming that 100 is going to be sufficient for my purposes. At the same time, since the stack is always empty to begin with, I need to initialize the value of top to -1. This is always the initial condition of an empty stack. Notice that top is simply an integer variable which denotes the current index of the stack. Now I will simply write, this is not a complete code, mind you, we are going to have a complete application program in which the whole complete program will be shown to you. Right now I will simply write the simple function codes for pop, push and isEmpty. How they are going to be used you will learn later in a bigger complete program. Consider this code for the function push. Just look at the header and the body. Push, as we understand, simply given a data value, it has to push the value onto the stack. Consider currently the stack is like that, empty stack, top is equal to -1. Now assume that this function is now called with this call push Assume that in the main function you have called the function like that, push 10. Now we know that the 10 will be copied into the formal argument data here. This function is called. Just consider what this function will achieve. The value in data isn't 10 right now. This code, 2 statements are executed. What is the effect? Let us see. Top is incremented by 1. What is the current value in top? Minus 1. So minus 1 becomes minus 1 plus 1. Top will be 0 now, because of this statement. Immediately the next statement, what are we doing? Into the array at the index top we want to put the data value. So what is top right now? 0. So a of 0. Into a of 0 what are we putting? Data. But what is data? Data is nothing but 10. So a of 0 gets the value 10. This is exactly what we wanted. So the implementation of the push operation into a stack represented as an array is very, very simple. As simple as these 2 lines. If again you call the same function twice more, let us say for example, if you consider these 2 statements also, push 20, push 30, for this one again what happens now? The value of top is 0, so it will be made 1 because of this statement. And then into a of top is a of 1 now. Into that data is currently 20, so 20 gets in here. Because of the third function call, the current value was 1, so 1 will be made as 2 because of this statement. And into that index array element, the value, current value data now has been set as 30, because 30 gets copied into data. The same 30 gets into a top. Right now a of top is a of 2, so a of 2 gets 30. So I hope it's clear. Push operation is very, very simple to implement. Just write a function like that, go on calling the function as and when you want to push an integer value into the stack. Now let us consider the pop function. This is how the pop function is written. It has a return value here. It returns an integer value because this is an integer stack. Name of the function is pop, and there are no arguments or no function arguments to this function. And this is how it is called in a code. That is pop, empty brackets, and of course it is assigned to a value x. Now what happens here when this function call is called? It comes here. These 2 statements, these 3 statements are executed. Let us see one by one. Look at the first statement. What is the value that gets copied into Q? A of top. The question is, what is top right now? Top is nothing but 2. So what is a of top? 30. So Q gets, next statement, top gets reduced by 1. So top will become 1. That is, now it will be pointing to 20. Look at the third statement. That is the end of the function. That is, it returns Q. What is the value in Q right now? 30. 30 gets returned. So where does the return value go? The function call has come from here. So whatever is returned by this function goes back to the function call. So 30 gets returned here, and ultimately that 30 gets copied into the x variable which has occurred in the original function call. So if you write code like that, x is equal to pop, what will you get in x? Whatever was there on the top of the stack. That is affected by these 3 lines of code. Just consider this very simple code which achieves in other function. Simply by calling the pop function, you will obtain whatever is there at the top of the stack. The same 3 lines can also be, the same 3 lines can also be condensed to a very simple line of code also, if you are interested. This one single line will achieve whatever we have written in the 3 lines earlier. Return a of top minus minus. This is a post decrement. So a of top will be returned and immediately top gets reduced. And one more thing I would like to add here, like I already told you, while you are popping, it is always necessary to check whether the stack is empty or not. So I will show you how that has to be incorporated here, because you can't simply call pop anytime you want. When you call pop, make sure that the stack is not empty. So whenever we want to pop, we need to check whether the stack is empty or not. So this is how we generally write the error correction code. We check whether the stack is empty or not. Look at this statement here. This is a function call is stack empty that returns true if the stack is empty, false if the stack is not empty. So if not is stack empty, that is if it is not empty, then you return the top element. Otherwise it is an error condition, just print stack empty and then terminate the program. So this is how we can generally write the code. I now want you to consider the code that is written for is stack empty. Notice that it is returning an integer value. It returns either 1 or 0. As you already know, 1 stands for true and 0 stands for false. That is the answer to this question, is stack empty? So if it is empty, it is going to say yes. Yes is 1. If the stack is not empty, that there are elements inside the stack, then it is going to return 0. So just look at this, if top is equal to -1. Our condition of stack empty is top being equal to -1. So if top is equal to -1, it is going to return a value of 1, which will be the answer to the question, is stack empty? Otherwise it is going to 0. So you have to understand what is the meaning of, if you receive 1, what is the meaning, and if you receive 0 when you call the function is stack empty, what is the meaning of that? That you can just put it alongside with what the code we have written for pop and see how these functions work with each other. So to summarize, stack is a dynamic data structure. It is an ordered list. Operations are carried out at the same end whether you push or pop. The fundamental characteristic of a stack is that it is a LIFO structure, LIFO, last in first out. Whatever you put in last will come out first, and in order to achieve this effect, usually we make use of 3 functions, which are pop, push and is stack empty. Thank you.